Hey everyone, Nitesh this side. So let's start with the question. So the question is combination sum. So you have given an array of distinct integer candidates and a target integer target. You have to return a list of all unique combination of the candidates where the chosen number sums to target. Okay, so your unique combination sum will be equal to target. You may return the combination in any order. Okay. The same number may be choose from the candidate an unlimited number of times. So you can choose the same number as unlimited times as you want. And two combination are unique if the frequency of at least one of the chosen number is different. So let's say you have a unique combination 111. So you can't choose again a subset as 111. Okay. And it is guaranteed that the number of unique combination that sum up to target is less than 50. Okay. So let's see with an example. Okay, so we have given this candidate array and we have given this target sum. So what we need to give is find the basically uh, sub array which will be equal to the target, and you can make any combination as you want. So you can take the 2 as many time as you want. You can take 3 as many time as you want. So let's see, we have this 2, 3, 6, 7, and we have a target of 7. Okay, so as you can see, if we use 2 times 2, 2, and 3, and if we calculate the sum for this, it's basically 2 plus 2 plus 3 is equal to 7. So this is our target sum. Let's see any other combination can we use with 3. No, I guess we are not having, or 6 will also not have any option. 7, we can use only the single element also. So as you can see, 7 will become this target. Okay, so we have two subset or a sub array. So you have to make the combination like this, and we have to give all the combination that you make. Okay, so let's see how we can approach this question. So if you can clearly see, we need the combination or the element that is less than or equal to target. Okay, so that means we have two options. Either we can take the element, let's say we have two options. This is yes. Either the current element is less than equal to target, then we'll consider it, and either we will just skip that element. Okay, because if that element, let's say, is 8 and the target is 7, so that doesn't make a sense to take this element, so we just skip that element. Okay, so let's say the function is like something solve this array. Let's take a starting pointer as I, and this is our target. So what we will do in this skip case, basically we will do solve array, and we just increment the pointer. Okay, and we will not decrease our target also. This skip is pretty clear. For the current, what we have also option, like we can take the same element as many as time as we want. So what we will do for here, so we will do solve array. We will not increase our pointer because we can take the same element as it is, and we will reduce our target. The target will now become array of I. Okay. So in this way, we can easily solve and get our subset. And what will be our base case, like where we have to return? So if your target is equal to 0, then what we will do, we will add this. Basically, you will take a list also, which will be you taking the current element always. So add it to that list, this current, and you will basically add to your final list. Okay, final dot add this list. And the one more base condition is if your target is basically less than 0, basically you didn't get that subject and your target is now in negative, so you don't want to continue, just return from here. So let's see this approach with an example. Okay, so now let's see the example of the previous approach that we discussed. So let's take one sublist also side by side, which will store the subset or the combination which is giving the target as sum. Okay, so we have two options. Either we will start from here, from our current, and we have two options. Either we will take it or either we will not take it. So let's say we take it. Okay, so we take it. What we will do, we will add this into our sublist also. So sublist is now become 2, and this will be, and we are not, whenever we take, we don't increase our counter. So basically, so pointer will remain point to 2 only, and our target reduced to 7 minus 2, which will become 5. So it will point it here only. And let's say we don't take it, so this will become 3, 6, 7, and target is 7. Okay, so let's solve first this part. Okay, so let's solve first this recursion call. So here again we have two options, either we will take it and either we will not take it. So if we take it, we will add it into sublist also, so it will become something like this, 2, 2, and this will point again to 2 only, and it is at here, and your target is now reduced, so it will become 3, and your, if we don't consider it, it will become something like 2, this will become 3, 6, 7, and target is remain as it is as 5. Okay, so let's solve first this part. So for this we again take it, it will become 2, 2, 2. So it will become 2, 2, 2, and it will be remain pointing to 2 only, and your target is now 1, it is pointing at here only, and this will become now 2, 2, we will not consider it, so it will become 3, 6, 7, and a target of 3. Let's solve this only. So we will consider this, it will become 2, 2, 2, and this will become pointing at only 2, 3, 6, 7, and our now target will become 1 minus 2, it will become minus 1. And let's say we will not consider it, so it will become something like 2, 2, and your pointer will become 2, 7, and target is 1. Okay, so if we call again, so we will check our base condition. Now base condition is target is now negative, so we will not go further, we will return from this call. Okay, so we will come back at this point. Okay, let's solve the right part. So for this, if we take it, so it will become 2, 2, 2, 3, and it target will become 1 minus 3, and it will be minus 2. So similarly target is also negative, and for all the case it will always be negative, so we will return out from this call also. Okay, so from here we are getting a empty, like no set, so it just return from here also. From here we are not getting any list or subsets. Now in this case, let's see, let's change the color, it will be more clear to you. So we are at here. Okay, so we have again two options, either we will take it or either we will not take it. Let's say we will take it, so it will become 2, 2, 3, and your becomes 6, 7. So, and your target is now 0. And let's say we will not take it, so it will become 2, 2, and it will become 6, 7, and your target is 3. Okay, so we will call again. So for this case, you can see this is your base case. So what we will do, we will take one result list also, because this in this case we are getting a target as 0, so it will become, so we will add it into our final list also, so it will add it like 2, 2. Okay, so we will return from this call, and let's say we will go for this call. So if we make the combination, you can say 2 plus 2 is 4, and if we make any other combination, it will be greater than our target. So 4 plus 6 is 10, and 4 plus 7 is also 11. So let's say the call will not give any sublist, so we will return from here also. Okay, so from this call we return. Okay, so now let's solve this call. So 2, 3, 6, 7. Okay, so as you can similarly see, we will go deep down and we'll create all the subarray. Okay, so similarly we will go for this array also, or get this array also, and from this we'll get 7 subarray, and which we will add it into our result. So this will be our final result. Okay, now let's calculate the time complexity for this. Okay, so before calculating the time complexity, let's write the code so it will be clear for you after this. So let's write the code. So what we need, a list of list integer. Let's name it as list equal to new array list. Okay. And what we will do, we will create one sublist also, which will pass in the function new array list. Okay. Then what we will do, we will call our function and we will pass solve this candidate array and your current pointer, which will start from 0. And what we will also pass is, let's pass, okay, we will pass target and our sublist. Okay, so let's write code for this. Like directly with solve, we will pass the array. Let's give it a small name. This will be our start, this will be our target, and this is our list, sublist basically. Okay, so first step is basically we need to iterate over all the elements. So what we will do, take a loop for int I, which will start from start basically, and it will go till nums dot length and I plus plus. So what we will do, either we will consider this or either we will not consider this. Okay, so let's say we will consider this. Okay, so what we will do, we will add this element into our sublist, and we will add the current element nums dot I, and we will call our recursion basically solve nums, and we will not increase our pointer, we will pass it as same, and we will decrease our target by nums I, and we will pass our sublist. Okay, so this is for left side, but for right side we are not considering this target. That means we have to remove this. Okay, so we will remove sublist dot remove nums I, and we will make, or let's remove it like this, remove the last element sublist dot size -1. Okay, so it will remove the last element because in the list this will be element is added in the last only. Okay, there is one case which we have to handle also. Let's say if your nums I is greater than your target, so that pretty clear we will not consider it, so we will just do continue. Basically we are skipping this element. Okay, let's write the base case also. The first base case is if your target is less than 0, so we just return, because we don't want the negative subs combination. And if your target equal to 0, what we will do, we will first add it to our final list, basically list dot add new array list. We will add this sublist inside this, and we just return after this. Okay, so this function, I guess it's complete, and after this, like combination sum, you are calling solve, so we need to return list also. Okay, let's run the code. So this is accepted. Let's submit this. As you can see, this is submitted. Okay, let's calculate the time complexity for this. Okay, so first, basically, as you can see at this point, what we are doing is basically taking the sublist and adding it to a list. So let's consider the sublist size as m. So the adding the all element to a new list, it will cause us order of m. And for this, if you can see what we so if you see what we are doing is basically creating all the, you can see the combination. So let's say if you have four position, so what you are doing, either you will take it or either you will skip it, either you will take it, either you will skip it. But in, let's say if you have only either take it or skip it, then you have only two options. So it will be two, 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 two. So it will become something like 2 to the power, let's take a k. Okay. But in this question, it's already mentioned like you can take the same element as it is, as you want. So as you can see, we are taking the same two at here also, at here also, at here also. So what we have an option, let's take an example. So if I have a 10 and array as 1, so what I will do, 10, basically it will become 9, then it will become 8, it will become 7. So what I'm doing is I am taking it as twice to the target, because I can take the same element as many as time as I want. So this will be the time complexity for generating all the subsequence, and the final will be order of 2 to the power target into m for adding all the sublist to a list. And space will be, you can consider a sublist size. So this will be your space complexity. Hope you liked my video. Thank you for watching this.